Hey there, it's Jason from Codemanship with a video about continuous integration and continuous delivery in Java. Continuous delivery is a term that's often used and much misunderstood. Most people take it to mean continuous release or continuous deployment, but that's not strictly speaking what continuous delivery is. It doesn't necessarily mean that we're continuously shipping our software, say several times a day or whatever. What it really means is that our software is continuously shippable. That is, it's in a state where we could release it if we wanted to. And that essentially puts the business in the driving seat. It allows them to bring changes into production or into release whenever they want, whenever they're ready, rather than waiting for the IT department to schedule a big bang release with testing, customer testing and stabilization phase, and et cetera, et cetera. So the sort of the business case behind continuous delivery is that the business can have features or changes as soon as they're ready. They don't have to wait. And that can dramatically reduce the cycle times when it comes to delivery. And that has a knock-on effect in all sorts of different ways on the software development lifecycle, but also on the business itself. It can make a big difference to a business if you can cut those delivery cycle times down from months to weeks or even days or hours. So when they ask for a new feature, they can have it within a few days rather than waiting for the next sort of big bang release. So it's something that a lot of businesses really want. It means that you can get feedback from trying stuff much sooner. It means that you can sort of reap the value from the investment you've made in software development sooner. And that's all good stuff. But it doesn't happen for free. It comes with some technical considerations, and that's what we're going to be demonstrating in this video today. Now, the first thing we need to think about, if we say the software is shippable, that means that it, number one, it works, and number two, it's somewhere where it can be shipped. So we need to be thinking about how often we're testing the software, and a prerequisite for continuous delivery is continuous testing, that the software is constantly being tested and retested, and that means that you need fast-running automated tests. So like I said, you don't get continuous delivery for free. You have to invest in those test suites. The other consideration is how often people are actually pushing their changes to the central repository, the code repo from which those release builds are being taken. If we're merging our code into the main branch or into the trunk, as we call it, say once a week, then by definition we can't achieve continuous delivery because the changes are sitting either on our own desktop or sitting in our own branches, say a feature branch, for example. So the other technical consideration is that we are continuously integrating our changes with everybody else's changes into the shared repository, into the trunk, as we call it, or the main branch. So what we're going to be demonstrating is this process of continuously integrating into trunk-based development, and we're going to show the relationship between that and unit tests to show how the whole process works. Now, what I've rigged up here is a little example. We're doing the CD warehouse example, and I've got two developers, Jason1 and Jason2. They're both me, and I've got two copies, two clones of our code base here on my desktop. Let's take a look. So there's copy number one that I'm working on, Jason number one. And I'm working on the buying a CD functionality. And there's copy number two. Jason number two is working on searching the catalog for CDs. And we've both been working, we've both reached stages where we would like to push our changes to the trunk, to the main branch. But we can't just go ahead and do that. We've got to be sure that if we're all merging to the trunk, that we're not going to end up breaking the code, breaking the build. And we'll explain why that's a very bad thing a bit later. So in order for me to safely push my changes to the same branch that everybody else is pushing to, if we're all pushing to the same branch, I need to go through a little dance. There's a little sort of safety procedure, if you like, that I need to do to make sure that I'm not risking breaking the build, or that it has the lowest risk possible. Now, the first thing we're going to do is we're just going to talk about this process, or the way that I do it. So a little bit of sort of the flow of the process I go through when I check in. First thing I need to do before I even think about checking in is make sure that what I've got here actually works. So I've run my tests and my tests are passing. That's fine. So I can now think about pushing to master. But before I do that, I need to make sure that I've got changes that anybody else has pushed to master, updated, merged into this code base here. So what I'm testing is not just my changes, but my changes with other changes that other developers have made. So before I do anything, I'm actually going to do a git pull, and I'm going to get any changes and merge those into this. Actually, let's do it JSON number 1 first. Merge these changes. We're going to do a git pull. So we've both been changing the code. Let's see. It'll probably give me a little warning. Oh, we're already up to date, so I haven't made any changes since, or no more changes have been pushed to the repository, pushed to the trunk branch since I last did an update. So we're good to go on that. Like I said, the tests are all passing. There's no changes, so I'm in a position where now I can push. So let's... And of course I will have done a commit before this. In fact, let's make sure that I have, actually. Yep. Actually, let's do the whole thing. Okay, add. Added tests for YCD. And okay, so there's a bunch of stuff that's been added there. That's good. And now, well, it'd probably be an idea just to make sure that nobody, we need to be mindful of this, nobody's been in there since I have. Good. So now let's push that. We're pushing it to a branch called trunk, which is the branch that everybody is pushing to. So there's no personal branches, no feature branches, but we'll talk about that later. Okay, and off it goes. Now that I've done that, a lot of developers kind of have a bit of a blind spot. They push and they go, right, that's me done. But no, we need to make sure that it builds and runs on somebody else's machine. So I've set up a build server here, a continuous integration server. There's a cloud-based product called Cloud CI that I use quite often. And what that's going to do is it's actually going to use Maven to build and test the code that's in the repository, the code that I've just pushed, on a different machine. And we do that for a number of reasons, the main one being to see that it does actually work on a different machine. So we can rule out the possibility that it's my local configuration that's making it work. So we've seen it work on a different machine, and now at that point the process is complete. Think of it as a single transaction from deciding that you want to push to actually seeing your pushed code, the code that you've changed, running and building and succeeding on a different machine on a build server like this. That's the complete transaction, and it's a green build. Always a good idea to just make sure that our tests have actually run. I find that I need to frequently check this. Okay, so let's just check the output from that. Okay, it ran 3 tests. That's good. So it's running the tests. So we can have some confidence that we have a working build, and if the business wanted to release that, they potentially could. Okay, now, let's go back to my pipelines. Let's just look at, so it's just the trunk branch we're interested in. So a sequence of green builds, and we're trying to keep that build green. That's kind of the art of continuous integration and what we call trunk-based development. Because we're not working on separate branches, we're merging into the main branch, the trunk. We need to be very disciplined about not breaking that. What happens if we do break it? Well, if the build is broken, nobody else can check in. It's not safe to check in, which means essentially you're blocking everybody else from delivering the changes that they've been working out. You're blocking value from getting into the pipeline now, potentially for a release. So it's really, although you'll probably be the one tasked with fixing it, it's really everybody's problem because now everybody is blocked. So what you would do if the build was broken, well, you've got 2 choices. You either fix it, and if you can't do that quickly, then maybe you should go for the second choice, which is you roll it back. You revert to a previous working commit and make sure that builds, and then everybody else is unblocked. So it's a single process. It all has to be done in a single step. And of course, the danger is that while I'm pushing to the trunk, somebody else will come in. So let's say, for example, I do a pull and I'm merging, and then I run my test, and that's all good. But in between me merging and running my test, somebody else has checked in on top of me with conflicting changes, then we potentially have a problem. Now, there are high-tech solutions to this, but I prefer low-tech. So if you're all working in the same team, or if you're working remotely with webcams, you could use something called a build token or a build lock. And this is some easily distinguished object, something that looks a little out of place in your office, that's kept in a shared place in the office. And what you will do then, if you want to go through that whole process of pulling, merging, running your tests, etc., and pushing and waiting for a green build, to stop anybody else, you would go and find this build token or this build lock. In this case, we're using a hat. You go get the hat and you put the hat on, and you're announcing to the rest of the team, I'm pushing, I'm the one merging at the moment, so please don't anybody else merge. So same principle as having a sort of a lock object in multi-threading. It's saying, no, if you can't get the hat, the build token, it could be a hat or a rubber chicken or anything that stands out, that's easy to see from across the room or on your webcams. Or if you're on Slack or something like that, you could have some kind of messaging thing that you do that say, okay, I'm pushing, please don't anyone else push, etc. But you need to make everyone else aware, and everyone needs to make an effort to be aware of who's merging at the moment and not to come in on top of them. So that's working, that's great. Now let's switch to JSON number 2. So I put my hat back because my build is succeeding. Now I've got some code that I think I would like to share with the rest of the team. So I go get the build token, I go get the hat and put that on so nobody else can come in on top of me here. And we go through a similar process. So first of all, I've made sure that all my tests are passing before I even think about merging. That's great. But now, let's commit that. Again, I probably need to add some files. Must really get into that habit. So I've added catalog search test. Okay, so we've added a couple of things there. Right, now at this point, I'm going to do a pull and then we're going to merge. And there's probably going to be some conflict, so let's find out. Okay, it's tried auto merging. Auto merge failed, so we're going to go and we'll have to go and take a look and see. I think the conflicts are in here. Let's get rid of my Maven window there so we can see a bit more clearly. Okay, so basically we've changed the constructor of the CD that was being used in the by CD tests. So we're going to need to, let's take a look at this. Okay, so we've got a bunch of stuff going on here. Let's see if we can fix this. We get rid of that. And we'll get rid of that. And that. The buying CD still works. That's still fine. I'm not sure why it's complaining about get stock. Has get stock changed? It's saying now there is no get stock method. That is interesting. Let's take a look in CD and see what's happened there. Okay, yeah, okay. We need to. This isn't compiling, so we need to fix some of this as well. So this is the constructor signature that we want. Okay, and that should fix CD. So when we go back to CD, the get stock should now work. Now let's fix that. And I think what's happening here is we've added a new exception that's being thrown. Plus we've changed there's a couple of things that have gone on here. So we need to merge these two lines. With the updated constructor, but also we've changed the signature of the buy method. And are there more? There's probably more down here. Similar kind of deal here. We've changed the signature of the constructor here, so we need to tried merging it, but it didn't. So I'm just going to use blank strings to represent the artist and title. And that's the price. So 10. Yeah, okay, there's a bunch of things going on here. I don't think we actually need the price. Okay. So I think we fixed all the stuff there. Sorry, that was a little longer than I was expecting it to be. But that's absolutely fine. Let's immediately then rerun our test. So at this point, we've merged. Let's find out if it works before we think about doing anything. Now, if you would like to please to run these tests. Okay, so we've got all of our tests are green now. That's looking good. And we should think now about committing this. So I'm wearing the hat. So at this point, nobody else can check in because it's not safe to. While I'm merging, let's... So we merged this and one's changes. And that's going to not work. That's better. Okay, and now the moment of truth. Let's push it to the trunk branch and see what happens. So the goal here is to make sure that whatever we're pushing has everyone else's changes in it, and very importantly, passes all of the tests. Now, we're not finished yet. We need to go and look and see. We're getting a build now. Have we broken the build? Let's find out. Now, the chances of this should be low because we're constantly making sure that our tests pass, and in particular, we're doing what's called a clean check-in. The clean check-in is a pattern that's described in Kent Beck's book on test-driven development. Basically, we don't check in code that hasn't passed the tests. Okay, so that's a green build, which means it is safe for me to take my hat off, put it back in its place for somebody else to check in their changes. And that's kind of the check-in dance that we have to do. If we're all merging our changes to the same branch, to the trunk, to avoid breaking that, we need to get into the habit, first of all, of keeping our local copy up to date with other people's changes. So you need to keep one eye on the build. Really, whenever you see a build go green, you need to think at some point after that of merging those changes so that you can see, rather than getting them all in one big go before you check in. But certainly before you're about to check in, make sure that you merge any changes and resolve any conflicts. You make sure, very importantly, that all of the tests are passing. You commit that, you push that to the trunk, and then you wait to get a corroborated build. You wait to see it build and all the tests pass on another machine, on a build server, for example, like the Cloud CI server that I'm using. And then we can have some confidence that what's sitting in our trunk repository is shippable. If the business, if the customer wanted to ship that, they could. And we put them in the driving seat. Of course, the process doesn't stop there. There's also then the question of how do we ship it? And I'm not going to demonstrate that in this video. It would be too long. But you would probably have a longer workflow, a longer pipeline, that once the build has succeeded, maybe the software is then deployed automatically into a staging area for customer testing or simulation or something like that. And then maybe from the staging area, the customer can press a button and then it's automatically rolled out into the production environment, or whatever your policy is. Some developers have a policy of, if a build succeeds, it automatically gets deployed into production. Other teams have a policy of, the customer has a button that they can press so that when they're happy with what they see, they can say, okay, that can go live, and you put the customer in the driving seat. It all depends on your situation. But in all of those situations, it's very, very important that whatever is sitting in version control, whatever your shared code base looks like, that it works, that it is shippable, and that's the basis of continuous delivery. Now, there will be lots of you out there looking at me going, why on earth would you be pushing your changes to the trunk, all to the same branch? Why not just have your own branch? Why not use a developer branch, or what some people call a feature branch? And there are all sorts of reasons why people are attracted to that idea. One reason they're attracted to that idea is because very often teams get a lot of pain when they merge infrequently. It can be very painful because you're having to merge lots of potentially conflicting changes together at the same time. So you get a kind of merge hell. And so developers become very averse to that. They become very afraid of that. So they think, well, if I work on my own branch, I don't need to worry about that until I'm ready to actually merge it into the main branch. Of course, the merge hell doesn't go away. It's just exactly the same as not using a branch, just having it sitting on your own PC or your Mac or whatever, and then deciding to push those changes to check in at the end of a few days or a week. So generally we find that long-lived branches, although they might make you feel comfortable and warm for a while, in reality they save the problems up for you, and also they prevent you from continuously delivering it. But one of the reasons that developers use these things called feature branches, these long-lived branches, is to prevent essentially releasing code for unfinished features. So the last thing I'm going to show you is another way of achieving that, of essentially not risking releasing unfinished features. So, customers or users are clicking on buttons for features that aren't built yet or are only half finished. But that allows you to have all the benefits of continuous integration, the frequent merging, the constant feedback, the corroborated builds, the communication with the rest of the team as to what's changing on an ongoing basis, all that good stuff. And in particular, the benefits to the business of continuous delivery, but at the same time being able to hide unfinished features from end users. So let's take a look. A little file that I've got in here, called features.toggle. You take a look at this little file here. Hopefully you can read that. So it's just a little text file, and all it does is it allows us, or allows our customer, to toggle features on and off when they're finished. So essentially the front end of our application, whether it's the UI or whether it's the API or whatever it is, will have an architecture such that you can wire in or unwire these features dynamically using a file like this, essentially. So the customer can say, okay, that's finished now. I've tested it. I'm happy. So let's switch that on. And then when that gets deployed to live, that feature is now visible to the end user, or it's accessible as part of an API. So feature toggles or feature flags are a very simple way of essentially hiding unfinished features from end users, so that we can get all the benefits of continuously merging our changes together and testing them together, and all the benefits of continuous delivery. But we're also getting the benefits of not releasing unfinished features that users can actually bump into. The equivalent of a half-finished bridge that doesn't have any roadblocks, essentially. So these are your roadblocks for your half-finished bridges. So that's continuous integration. It's underpinned by two technical practices. One is continuous testing, which requires high levels of test automation. And the other is continuous integration or trunk-based development. We're all merging our changes to a shared branch we often refer to as the trunk. It takes some discipline. The most important thing to remember is that you need to make sure that you've got everybody else's changes successfully merged into your changes, and that those changes pass all of the tests before you even think about pushing those changes into a shared branch. You need a corroborated build. So you need to see a build and the test pass on another machine before you're done, basically, before you can put your hat back and say, okay, somebody else is now safe to check in. If you break the build, you're blocking the rest of the team, and it is the rest of the team's problem as well. So your choices are very simple. You can either fix it quickly, or if you can't fix it quickly, you need to roll it back so you can free up the pipeline for the rest of the team, the delivery pipeline. One final word. If you're watching these builds run on Circle CI here, we look at our status page there, you'll see that builds have a duration. Now, these are very short builds because it's a very small solution, but as your solution grows, these build times are going to get longer and longer. And as your code base grows, tends to be the thing that takes up the lion's share of the build time is running the tests. If your tests take a very long time to run, I've worked with clients who test suites took hours to run, then your build cycles are going to be very slow. And the build cycle, the time that it takes to do the build, is a bit like it sort of dictates the metabolism of your delivery cycle. If you have a slow build cycle, you will have slow delivery cycles and a slow pace of development. It would be very, very difficult to achieve continuous delivery. And that has a profound effect on the whole process. I've seen speeding up build times have an extraordinary impact on a team in terms of freeing them up, removing bottlenecks, and et cetera, but also leading on from that, it can have an extraordinary impact on a business. You can't achieve continuous delivery without continuous testing. If your tests are slow, you can't do continuous testing. If your build cycles are slow, then the impact of that on the business can be very profound. I've seen some very big businesses, billion-dollar businesses, brought to their knees ultimately by how long it took to retest their software. For example, I was working with a client a couple of years ago whose test suite took 3 days to run. So realistically, they're only testing it once or twice a week, which meant that the thing was constantly broken, therefore not shippable. So their overall delivery cycles were very, very slow. By speeding up those test suites from days down to hours and then hours down to minutes, a lot of problems strangely disappeared. And one of the biggest problems was delivering the wrong thing. See, I have a theory about this, and it's a bit more than a theory, really. It's based on experience. But over the years, I've got less and less concerned about whether or not we're delivering exactly the right thing, just as long as we can find out quickly, and it will be easy to change so we can have another go, and have another go, and have another go. So those feedback cycles of delivery, getting working software in the hands of real customers, real end users, need to be really, really quick so that we can kind of learn our way to building the right thing. And I've found that that is the best way to do it. It's the fastest way to do it. But it has all these technical implications. You don't just get it for free. So you need to invest. And there are many companies out there, many teams who aren't willing to make the kind of investment, particularly in test automation and build automation and release automation, and in skills and training and all these other things that you need to invest in. Typically, between 20 and 25% of everything you spend on software development will be spent on things like build automation and test automation and optimization and all of these things. A lot of teams, they won't make that investment up front, but I guarantee you they pay 10 times as much downstream because of the impact of slow delivery, slow release cycles. So it is worth investing, but I appreciate it can be a hard sell to say, if you're a team of 5 developers, one of them is going to be working on tooling and builds and all that kind of thing at any point in time. So you're going to be investing that. And at the beginning of the project, probably everybody's going to be working on it. You've got to shave those yaks. And when we do exercises that are centered around continuous delivery, my advice to teams is always, look, figure out what you need to deliver, what the end result is. So, for example, if you need to get something on a website or deployed on an Android handset or something like that, get Hello World delivered. Do that first. Build the whole pipeline so that code that you're writing on your desktop is appearing on the phone or on the website or wherever it needs to be. Get Hello World working end to end, not just in terms of the architecture, the tech stack, but in terms of that delivery pipeline. Get the whole thing working and make it as quick and as frictionless and as reliable as you possibly can. Really is worth investing in that. The difference, it's night and day really when you see a team with short build cycles and teams with long build cycles. It's quite amazing really. So there you go. That's trunk-based development, continuous integration, and continuous delivery. It is kind of the ultimate end goal of code craft, is the ability to get those frequent release cycles, be learning from releases very, very frequently, and to be able, through good code quality, clean code, and all that good stuff, to be able to sustain that release cycle, that pace of release, almost indefinitely for as long as possible, so we can give our customer more throws of the dice, basically. So it's important stuff. Takes work. There's a lot of skills involved. There's a lot of tools involved. There's a lot to learn. A lot of developers don't like learning this stuff. It is taking us into DevOps territory, but it is important, and you need to learn it, and you need to master this.